Today we prove that A union B intersection C equal to A union B intersection A union C, which is distributive law. Now let us take an element X which is belongs to A union B intersection C. This implies that X belongs to A or X belongs to B intersection C. That is, X belongs to A or X belongs to B or X belongs to C. That is, X belongs to A. Sorry, this is not or, this is and. So X belongs to A or X belongs to B and X belongs to A or X belongs to C. So we get X belongs to A union B and X belongs to A union C. That is, X belongs to A union B intersection A union C. Okay. Why we write and? Since there is the sign of intersection is used, so we replace intersection by and we replace union by or. Okay. Now we write, therefore we write that A union B intersection C subset or equal to A union B intersection A union C. This is our expression number 1. Okay. Now I remove this portion and also let Y belongs to A union B intersection A union C. That is, Y belongs to A union B and Y belongs to A union C. That is, Y belongs to A or Y belongs to B and Y belongs to A or Y belongs to C. Then we can write this form as Y belongs to A or Y belongs to B and Y belongs to C. That is, Y belongs to A or Y belongs to B intersection C. That is, Y belongs to A union B intersection C. Okay. Then we can write that A union B intersection A union C subset or equal to A union B intersection C. This is the expression number 2. Okay. Now from 1 and 2, we get A union B intersection C is equal to A union B intersection A union C. Hence proved. Okay. So we prove this distributive law by some laws of set theory. Okay. Now we prove this distributive law by Venn diagram. First we draw a universal set U. Since here 3 sets are present and both are non-empty, so we draw 3 sets A, B and C. Now first we shaded the portion A. Okay. Next we shaded the portion B intersection C. Which is B intersection C? This common part of B and C is the shaded portion for B intersection C. Now we draw another Venn diagram U, and here also 3 sets are present, that is A, B and C. Now since the relation between A and B intersection C is union. So in this Venn diagram we have to shaded the part, that is the whole portion okay. So this is for A union B intersection C. This is the Venn diagram for A union B intersection C. Now next, for this right hand side we first draw an universal set U, and here also we draw three non-empty set A, B and C. Here we shaded this portion A union B. Here this part A union B is this shaded portion. Now we shaded the part A union C. A union C means the whole portion of A and C. Okay. Now we draw another Venn diagram. Three sets A, B and C. Since the relation between A union B and A union C is intersection, so from this Venn diagram we only shaded the common part. Here the common part is this portion. So this is the Venn diagram for A union B intersection A union C. Since both the Venn diagram denote that both are same, so we prove this distributive law by the method of Venn diagram. Okay, note down this portion. Now I will give you a homework. If here A intersection B union C, that is we get A intersection B union A intersection C. This is also the distributive law, and this is your homework. You prove this law by sets algebra, by the method of sets algebra, and also this Venn diagram. Okay. Now I remove this portion. Now our next law is prove that A intersection B complement equal to A complement union B complement. Okay, this is De Morgan's law, which is a very important law. Now let us take an element X belongs to A intersection B complement. Okay, then we can write that X does not belongs to A intersection B. That is, if X is present in A intersection B complement, then X does not belongs to A intersection B. That is, X does not belongs to A and X does not belongs to B. Here you notice that here notice that here the sign intersection is present. So for intersection we write and, but for the case of does not belongs to, we write the opposite meaning. That is, for intersection we write or, and for union we write and. Okay. So X does not belongs to A or X does not belongs to B. That is, X belongs to A complement or X belongs to B complement, that is X belongs to A complement union B complement. Okay. Now from this portion we write that A intersection B whole complement is a subset or equal to A complement union B complement. This is our expression number 1. Okay. Now for the second part, let us take an element Y which is belongs to A complement union B complement. That is Y belongs to A complement or Y belongs to B complement. That is Y does not belongs to A or Y does not belongs to B. Okay. That is Y does not belongs to A intersection B. Here also or denote this sign intersection because does not belongs to is present here. ঠিক আছে. Next, Y belongs to A intersection B complement. Okay. So we can write from this portion that A complement union B complement subset or equal to A intersection B whole complement, which is expression number 2. And from 1 and 2 we can write that A intersection B whole complement is equal to A complement union B complement. So by the method of set algebra we prove this De Morgan's law. Now by using Venn diagram we also prove this part by Venn diagram. First draw a universal set and here these two sets A and B. Okay. Now first we draw A intersection B. The portion A intersection B denotes only this portion, and the portion A intersection B whole complement, that is the part which does not contain A intersection B. So here the shaded portion is this part. Okay. So this is for A intersection B whole complement. Now we draw another Venn diagram A and B. Here we first draw the portion A complement, that is the portion without A. So the portion without A this portion, and now we draw B complement. B complement means the portion without B. The portion without B is okay, this portion. Now here we draw the portion A complement union B complement. Since here complement is present, union is present, so the portion A complement union B complement is this portion, which is similar to A intersection B whole complement. Okay. So also by Venn diagram we prove that A intersection B whole complement is equal to A complement union B complement. Now note down this portion.